Alright, finally we are now into the Fourier series. But before we going that, I highly encourage you to watch the previous segments, okay? And then what I did was I introduced you a set of real valued functions that is orthogonal on an interval, and I define the interval as a to b, right? And I also define an f, a function, in the same interval. Then I showed you that we can formally expand this f in an orthogonal series in this particular manner. C0, phi 0, x plus C1, phi 1, x, and I go all the way to the infinity, right? So I've shown you that. Right now what I'm going to do is I'm going to make a special case of what I just talked about, okay? And I'll make the expansion with respect to a trigonometric series. A Fourier series of a function, just like the function that I have up there, and let's be more specific, f of x, is the representation of that function using trigonometric series such as sine and cosine, okay? And I will go ahead and try to find my coefficients that I have over here, right? And let me talk about this set that I have. And this set will be cosine of 0, which is 1. Do you remember I saw the example? It was like 1 cosine x, cosine 2x, cosine 3x. Remember that? And I showed you that that was orthogonal. So I will do the little bit modified version of it, pi x by p, all right? And then I'll go to cosine 2 pi x by p. What is p? Just wait, give me 1 second. And I can do cosine of 3 pi x by p. Okay, so this will go to infinity. But now I'm not quite done yet. The first one, I'm going to also do the signs. When I put x is equal to 0 over here with a sign, you'll see that I'm going to get 0, so I'm not going to write this over here. So I'll start with sine of pi x by p, sine of 2 pi x by p, sine of 3 pi x by p, and again all the way to infinity. Okay. Now we talked about this p. This is kind of like, what is it? Well, let me relate to what's going on over here. This is the interval that I'm defining this at, right? So for instance, at one particular boundary, if I put minus p over here, I'm going to get a cosine minus pi in that particular case. Okay, so you'll see how we do it. We need to determine the coefficients, as I mentioned up here, right? So we have a bunch of these coefficients, so I have to determine the coefficients. So what I did was, we represent the Fourier series in this particular manner, a0 by 2. Okay, don't ask why there's a divided by 2. I will explain that when I do the derivation. Okay, summation from n is equal to 1 to infinity. I'll have an times cosine of n pi x by p plus bn times sine n pi x by p. Okay, obviously this needs to be in this parentheses, right? Because I'm summing the both components, both this component and both that component. Alright, so now the question is, alright, so let me recap what I've been doing so far. Fairly not too much, but I introduced the Fourier series, or orthogonal series expansion. It was a special case by using the sines and cosines, okay? And I went ahead and write an equation in here that I want to expand, but the question remains, what is a0, what is an, and what is bn? For the rest of this particular module, which may be a little bit more involved, you will see that the whole goal is to find a0, an, and bn. So I'll start with the first one. I'll go ahead and find a0, then I'll proceed to an, then I'll proceed to bn, all right? And what we learn here will be very important, and at the end of the day I will write what a0 is, an is, and bn is, and box it up and call it a day, okay? So in order to accomplish these a0, an, and bn, I'm going to take advantage of the orthogonality properties of sine and cosine series, all right? So the first thing I want to do is let's change color. The goal is to find a0. That's the first thing I want to do. Okay. So in order to accomplish that, what I will do is I'll take the integral of this equation that you're looking at, and I'll take the integral from minus p to p. Because why? Because the interval is minus p to p. All right. And then the left-hand side will be f of x dx. Obviously, I'm taking the integral with respect to the x. It makes a lot of sense because I don't see any other variable over here, right? The right-hand side will be a0 by 2, because that's a constant, minus p to p dx, plus over the summation sign, n is equal to 1 to all the way to infinity. I will have this an, because it's a constant, minus p 2p cosine of n pi x by p dx plus bn, again integral minus p to p, sine n pi x by p dx. Okay? Okay, the first thing I will do is look at this term. Let's take a look at it. Integral from minus p to p cosine of n pi x by p. Actually, I did this type of analysis in the previous segments, so I'm repeating myself. But this is fairly easy to take the derivative of, or rather integral of, and you'll see that you're going to get p by n pi sine of n pi x by p. Obviously, integration limits from minus p to p. And if I plug that in, you will see that I'll get myself p by n pi, and then I'll have sine. If I plug here p, I will get n pi, right? And if I plug minus pi, I'll get myself minus n pi. Okay. I explained this in multiple examples in the previous segment, but this will be 0 regardless of what the n value is. When n is equal to 1, it's going to be sine of pi, which is 0, and I have a 2 pi, 3 pi, 4 pi, all of them will be 0. From the same logic, if you put minus pi and pi, as we discussed in the previous segment as well, so basically in one case, whether I'm going from here to here versus I'm going here to here, I will get myself 0 as well, doesn't really matter, okay? So you can see this is going to be 0 as well. So now this term dropped out. You see what happened? So this term dropped out. So far so good. So the next thing I will do is I will look at, let's red color to this, that's my goal now. So let's write it, minus pi p to p sine n pi x by p dx. So this will be, again, very similar, pi by n pi. This time around there will be a negative cosine of n pi x by p, and I have to evaluate this from p minus p right down there, okay? And if I plug it in, I'll take the negative outside, minus p by n pi, and I will have cosine of n pi minus cosine of minus n pi, okay? Okay, this looks a little bit different. I don't think I've approached this particular case. I'm not sure you do remember, but I'm going to draw this again. So this is my, this is the cosine, right? This is the sine. And let's pick a particular, degree. Let's say this degree. And let's have the negative of it. So this angle and this angle is equal to same. Do you see that they are the same values right here in the x-axis? Intersecting point is still the same. So whatever the value of this is, this will be identical to that, okay? But remember, I'm making this comment for a general cosine. I'm not talking about n pi just yet. I'll come back to that, right? This and this is actually the same, and you're going to get 0, right? So the cosine n pi will be equal to cosine of minus n pi. The other thing specific about the n pi this time around is that, when I put n is equal to 1, what will happen is I'll get a, I will be at this point, right? And I will get myself minus 1. When I put n is equal to 2, it will be cosine of 2 pi, it will be 1. You see, 3 minus 1, 4. So what is going on over here is if I have a even, I'm going to get a plus 1. If I have a odd, I'm going to get a negative 1. So you can actually represent this. I don't need this point, okay? I already established that this is 0, but I'm giving additional information. I'll need this. So cosine 1 to the power of n, you can represent this as cosine of n pi, okay? Like I said, when you put n is equal to 1, you're going to get minus 1. You put 2 pi, cosine of 2 pi is plus 1. But you're going to get 0 over here. So if I go back up here, okay, this term dropped out as well. So this thing and this thing is dropped out. So I only have 2 terms over here. 1 term here, 1 term here. So far so good. So let me write what I just said. So it's going to be minus p to p f of x times dx will be equal to a0 by 2 minus p to p dx. So a0 by 2, I'm taking the angle of the right hand side. So that's going to be x from p to minus p. So you can see here is equal to a0 by 2. And this is going to be, basically p minus p, right? So that's going to be 2p. And you can see why I have 2 now, okay? If I didn't have that, you can see what a0 is. From here, I will get my a0 to be 1 over p, don't forget the p, integral from minus p to p f of x dx. So if I don't have a0 by 2, then this is not going to be like this. If I had a0 over here instead of 2, basically I need to multiply this by 2. You can do that. I have seen some books mentioning that way. That's acceptable as long as you know what you're doing. There's no problem, right? So now I have accomplished what I needed. I have accomplished what my A0 is. Okay, just to recap one more time, the goal here was I just take the integral of both sides of this original equation that is given to me from minus p to p, and I showed you that the summation sign, the first term in the summation sign is 0. The second term is 0. I only left with this. I evaluated it, and I simply get myself a nice equation for A0. Now the question is, I have my A0. How am I going to do AN and BN? So in order to do that, now I will take, I will look at this particular equation, and I will multiply this whole equation by cosine of m pi x by p, and then integrate both sides just like I did. So everywhere that you see in here, it will be cosine m. M is different than n. You can see cosine m pi x by p and go from there. Okay. Then I'll take advantage of trigonometric identities and find myself. You'll see I will get myself an. Okay. So let's accomplish what I just said. So my goal is to find now an value. I find a0. Now I need to do an. So I multiply both sides to the equation by cosine of m pi x by p dx will be equal to a0 by 2 integral minus p to p cosine of m pi x by p dx plus the last two terms. So it's going to be summation sign from n is equal to 1, not 0, right? Because a0 is here. That's why I put 1 in here. an minus p to p cosine of m pi x by p times cosine of n pi x by p plus bn integral minus p to p. This time around it's going to be cosine m pi x by p times sine n pi x by p dx. Okay, you can see I evaluated over here cosine. Where is it? Right here. The cosine, it was n, now it's m, but doesn't matter. This will be 0. Okay, so this will be 0, so this will be gone. Okay, so I'm not going to show you the details about that one because I want to get going. So now I will, as I mentioned, this is actually this an will be left, you will see soon, but this bn, this term will be 0. So let me show you how it goes to 0, because that I didn't do that just yet. Okay, so let's do it. Minus p to p. Now I have myself sine of n pi x by p times cosine of m pi x by p dx. Okay. The one thing to note is I have mentioned in the previous segment as well, but this will be the trigonometric identity for this sine cosine. Okay, plus sine of alpha plus beta. Okay, so this was, so let me go ahead and use this. So I'll have minus p to p 1/2 sine cosine, so it's going to be sine n minus m pi x by p dx plus integral minus p to p 1/2 sine, this time I'm adding them up, n plus m pi x by p dx. Okay, let's take the integral. Minus p by, let's not forget 2, n minus m times pi, and then cosine n minus m pi x by p dx. I'm going to evaluate this from minus p to p, and similarly the second term will be plus, but the integral of sine is minus cosine, so it's going to be minus p by 2 n plus m times pi cosine of n plus m pi x by p. I will have to plug this from minus p to p. Okay, good. So let me go ahead and so this is going to be minus p by 2 n minus m times pi, and then this will be when I plug cosine when x is equal to p, p's will cancel, so I'm going to get myself n minus m pi minus, let's actually continue this, when I plug cosine n minus m minus pi, right? That's what I get. Okay, and the second term will be now minus p, exactly the same thing, but this time around it's n plus m pi, and then in bracket, let's go to the next line, so it's going to be cosine, but not n plus m pi minus cosine n plus m minus pi. Okay, this bracket is closed. Okay, so here we go. This looks very similar to what we have done before. Cosine n minus m. I can call n minus m is equal to s, right? So this, as the cosine, is symmetric, and I'm going to actually use it in the Fourier series, sine and cosine. It's coming up in maybe in 5 segments or so. So this will be equal to that. Okay, I forgot to close the parentheses. So from here you can see that this will be gone, this will be gone. Same logic, n plus m. Now I'm going to call this, I don't know, p. No, let's not call it p. T. You know, cosine n plus m, instead of n plus m, I'll call it t. But at the end of the day, this term will be equal to this term, so that will be gone. So you can see here what happened right here. What happened is I get myself 0. So if I go back up here, what you're going to see is, yep, there we go. Look here. Let's do red. This term turns out to be 0, so bn is dropped. So you can see clearly here that then this term is equal to that term. Okay, so left hand side I can't do much about it as because I don't know what fx is. It can be anything, right? But right hand side I see a cosine, very similar to what I did with cosine and sine. I'll now do the similar approach to this and see what happens. Okay, so I'll do the same now. Unfortunately, this will be as long as this one, so it may take a little bit of a while, but what can I do, right? You know, I gotta do what I gotta do. So this is from minus p to p, cosine n pi x by p times cosine m pi x by p dx. And I'm gonna write a note here. Let's write colorful so I don't forget this note. Cosine alpha times cosine beta will be equal to 1/2 of cosine alpha minus beta plus cosine alpha plus beta. Okay? So you can see you just simply sum them up. It's much more straightforward than sine cosine multiplication. Okay, so now let's apply this to what we have. Let's go back to the green font. So I'm gonna have myself minus p to p 1/2 cosine of n minus m pi x by p dx plus 1/2 minus p to p. Doesn't matter where you put 1/2, it's a constant. Cosine. Now n plus m pi x by p dx. And I do the exact same thing that I did in the previous step. So I'll do p divided by, let's see, n minus m times pi times sine. I don't have a negative this time around. N minus m pi x by p. I have to delete this from minus p to p plus, well, same thing with n plus m this time. N plus m pi sine n plus m pi x by p, again minus p to p. Nice. So now I'll do two approaches over here. Okay, the first approach that I'm going to do is if, okay, let's write it over here, if m is not equal to n. Okay, if m is not equal to n, what will happen is, I'm not going to go through the steps again, but when you plug it here, this whole n minus m, right? If you plug p, for instance, x, so this will cancel. You're going to see you're going to get sine n minus n times pi, which is 0. Then when you plug negative p, you're going to get n minus m times negative p, that is 0. So this term will drop. Exact same logic, because n minus m is, let's say, k, and plus m is equal to t, so it doesn't really matter. So both terms will drop out. Okay, so you can try this at home if you choose to, but you will get yourself a 0. Okay, the approach is very similar to what I've been doing over here, except now this will be basically sine, which is 0. This will be sine, which is 0. This will be sine, which is 0. This will be sine, which is 0. So I'm choosing not to write it for brevity of this particular segment, which has been very, very long anyways. Okay, and the second if condition is if m is equal to n. And you may be asking me, well, wait a second, you haven't really done this approach so far, why are you doing it now? Well, let me tell you why am I doing this now. If n is equal to m, I cannot proceed with this. The reason why I can't do this is, look at this n minus m. So now I'm going to get myself p divided by 0 times sine 0, which is 0. Okay, so you get yourself p times 0 by 0, so that's the indeterminate. So I have to try something else. So, okay, let's go back to the original. Don't panic, it's not going to be as long as what I've done. I look at here now. Okay, actually, why don't I just copy paste? Give me 1 second, I'll be back. Okay, simply I'm gonna delete this. Now N and M doesn't matter, it's the same letter, so you can use, you know, either M or N, but let's use N. Now I got myself cosine square, so you can see over here, right? So cosine square. So let's write it in here now, cosine square. So I'm gonna use a trigonometric identity. So as this is a cosine square, I'm gonna use cosine of 2 theta is equal to 2 times cosine square theta minus 1. So from here I get myself cosine square theta will be equal to cosine 2 theta plus 1, but then I have to multiply this whole thing by 1/2. Okay, sorry, I had to write it at the end. Okay, so now I'll go back and use exactly what I said. So it's going to be minus p to p. Now instead of cos square, I'm going to write 1/2, and let's do a proper job. So it's going to be 1 plus cosine of 2 times this. So it's going to be 2n pi x by p dx. Okay. So now if I take the integral of this, what you will see is, well, 1/2 will be out. The integral of the first one will be x, and the second one will be sine, cosine. So it's going to be p by 2n pi, okay, sine of, well, the same, 2n pi x by p. And I have to evaluate this from minus p to p, okay. So let's do exactly what I said. Let's evaluate from minus p to p. So 1/2. So this will be x will be p minus p. The second one will be p by 2n pi parentheses of sine. When I put p here, it will be 2n pi minus sine minus 2n pi. Okay, and we have covered this many times, so I'm not gonna spend a lot of time, but this will be 0, this will be 0. I only have 2n, but you can call 2n is equal to, you know, some other letter, right? So you can see this, you get yourself 0 over here, and if I go back over here, then let me actually close the parentheses here, I need another bracket. So you can see this is gone, but this I get myself 2p. So 2p by p, 2 is p. Okay, so far okay, I'm not panicking now, so let me go back. So when I go back up here, you will see that this whole thing right here turns out to be just a p. Okay, so then in order to find an, I'm going to divide this by, or rather multiply by 1 by p. That's it. Okay, let's just write what I said. Okay, so from here, I will get myself an will be equal to 1 by p integral minus p to p f of x times cosine of n pi x by p dx, and I box this up, right? Okay, so this has been a very long segment, so I'm gonna stop right here and I'm gonna pick it up from calculating the bn. All right, I'll be right back. Thank you for watching this particular segment.